Hello students, welcome to the video lecture on BZT configurations. I have presented in the earlier video. I have explained the basics of BZT bipolar junction transistor and its construction, types of transistors and about the terminals, etc. In this video, we will try to understand what are the various BZT bipolar junction transistor configurations and their properties, their features. Let us start. As all of you know, through my earlier video, I have explained that a transistor is basically a three-terminal device. A transistor is basically a three-terminal device, either NPN or PNP, whatever it may be. It has three terminals, namely base, collector, emitter. Whatever the type may be, either PNP or NPN. I repeat again, it has three terminals. If you remember, the arrow mark downside indicates NPN, arrow mark upside indicates PNP. But when I wish to connect or when I wish to use this transistor in any circuit, how do we connect this? Actually, I have to apply some input at the base, and this will be the ground normally, and I must apply something to the collector. So I must have a terminal here. So if you observe carefully, we can call this port as input port, input. So it is a port, and this is your output. Such configurations are called two-port networks. You might have come across in your network theorems or circuit analysis or any subject. In such subjects, you come across about a two-port network. What is a two-port network? Actually, a network is a block diagram, simple block diagram. A network which has two ports, that is one input port and one output port. Hence, it is called a two-port network. So, based on this connection or arrangement, a transistor can also be equally considered as a two-port network. I have one input port here, and I have another port as output port. Now, the problem is when I have two-port network, I should have two input terminals. I can say 1 1 prime, 2 2 prime. Okay, 1 1 prime, 2 2 prime. That is total. I want 4 terminals. But when you take up your transistor, there are only 3 terminals: emitter, base, collector, whether NPN or PNP. This is the actual trick here, because a transistor has only 3 terminals. Either NPN or PNP. But if I want to use this in a circuit as a two-port network with input and output ports, I need 4 terminals. Remember, I need 4 terminals to use this as a two-port network. Then what to do? So the scientists and engineers have given us a trick. So why should not we use one of the 3 ports common to both input and output? One of the terminals, because I have 3 terminals: emitter, base, collector. If I use any one of the terminal as common, that is, it will act both as input terminal as well as output terminal, then you get your 4 terminals. That means your transistor can be connected or used as a two-port network. This is the basic trick that we use. Based on this, we have, because it has 3 terminals, I can't say that I use only emitter or base. Some people may say, why should not use base? Why should not use collector? Therefore, I may use emitter as common to both input and output at one time. Then it will become common emitter configuration. Some people may try to use base as common to both input and output. Then it may be called as common base configuration. Some people may use collector or if common collector configurations. That is making one terminal common to both input and output. Both input as well as output. I think I am clear. It is called as common emitter configuration, and this can be used in your circuits to study the characteristics, to use it as an amplifier, to use it as an oscillator for any purpose, because I need one input, I need one output. Especially for amplifiers or to study the characteristics, I have to give both inputs and take the outputs. This is the basic idea of these configurations. This is the basic idea of the configurations. So as a transistor has only 3 terminals, to use this as a 2-port network with 4 terminals, we consider one terminal as common to both input and output. Hence, as transistor has 3 terminals, we have 3 types of configurations. This is the most important thing. This is what I have explained in this slide. A transistor is similar to a 2-port network. That is one input port with 2 terminals, one input port with 2 terminals, and one output port with 2 more terminals. Total 4 terminals. But the transistor, as you have seen in the explanation, only 3 terminals. Hence, to make this or to use them as a 2-port network in a circuit, I require 4 terminals. Hence, one terminal is used as a common terminal. Now the question will be, as I have already explained, which terminal? Therefore, we use all the 3 terminals, and hence we have 3 types of configurations. In this video, I will try to explain the basic ideas of transistor configurations. I don't go to the characteristics, etc. We'll discuss them at some other time with some other video. Here, the most basic points. What are the 3 types of configuration? What are their properties? Let us discuss. So, as you know already, I have 3 configurations: common emitter, common base, common collector configurations. Then what is the definition of this common emitter? It is the configuration in which emitter terminal is common to both input and output terminals. And remember, this is a very widely used configuration. We will understand why after in the next slides. Through the next slides, we will understand why. But remember, the CE configuration is a very popular configuration for the students in the labs, practicals, or etc. In the earlier, that is basic studies, we mainly concentrate on common emitter because other configurations have some limitations and they have some specific application. Let us see. So this is the basic circuit of common emitter configuration. If you see, this is collector, base emitter. I have shown the diagram like this. And this is the input. I made the emitter both at the input side as well as output side. That means base emitter is the input port, emitter collector is the output. This is the schematic in the circuit with the symbol. Base emitter is the input, emitter collector is the output. Here you can very clearly see that this emitter is common to both input as well as output. Hence, it is a common emitter configuration. Let us see some of the properties or features of the CE configuration. In this configuration, the input parameters are VBE and IB, and output parameters are VCE and IC. You can see the diagram. VBE, base emitter voltage, VCE, IB, base current, IC. So input voltage is VBE, input current is IB, output voltage is VCE, output current is IC. That's what we have seen here, or what we think I have gone to count here. VBE, IB, and this is VCE, IC. This configuration has medium input and output impedances. That means input impedance means resistance, a kind of resistance. That's it. So it has neither high input impedance nor very low output impedance, average or medium. That's why it is very widely used. It means not very high and not very low. And another thing is its current and voltage gains are also medium. That's very important. And the most important or salient feature is in common emitter configuration, it always introduces a phase difference of 180 degrees between input and output. Remember, very important. If I give an input like this and the output will be always like this, 180-degree phase difference, either especially amplifiers or anywhere. If the input is like this, output is like this. So what is the phase difference? This is 180 degrees. So the reason we will discuss while discussing the amplifiers. Don't bother. For this part, you remember that a CE configuration always introduces a phase difference of 180 between input and output. This is very important. Similarly, common base configuration. As you know already, common base means base is common to both input as well as output. Base is common grounded to input as well as output. So input is taken between base emitter, input is applied between base emitter, output is taken between base collector. Therefore, what is the voltage here? Input voltage is VBE, output voltage is here VBC. VBC. This is what we have explained in this slide. So as I already told you, VBE and I is the VBC or VCB and IC. So the current gain is less than or equal to unity. That's important. For common base, the current gain is very less, but the voltage gain is very high. So current gain is less, voltage gain is high. And input and output are in phase. That means there will be no inversion, non-inverting configuration. That means if I give an input like this, I get an output like same phase. Whereas in our common emitter, if I have given an input like this, I have explained earlier also, this will be pulled up. That means a phase difference of 180. This is for common emitter, but common base has no such feature. So this is the reason non-inverting, we call this as a non-inverting configuration, right? So similarly, third one is common collector configuration, CC configuration. This has many specific applications, though we may not use this as an amplifier due to some reasons. I will come in the next slide, but it has some specific applications like buffer. We'll discuss this. We'll understand very soon. So as the name implies, collector is common to both input and output. That is, input is between base collector, output is between emitter collector. Of course, in practical circuits, this may be indicated differently. That's a different issue circuit. But commonly to understand, between base and collector, input is given, emitter collector output. So collector is common to both input and output. So VBC is the input parameter, base current and VBC. Emitter collector is the voltage output and emitter current is the current. So emitter current and VBC, base current and VBC. These are the parameters, voltage and currents for a common collector configuration. So then what are the other important properties, features? In this configuration, as I've already told you, input is applied between base and collector, VCE, IE and VBC, IB. This way. But most important thing is, the common collector configuration has very high input impedance and low output impedance. Practically, this is the most required parameter. But unfortunately, it is not an amplifier. That is the problem. Otherwise, that's why it is mainly used as a buffer circuit. Another most important thing is, it is also non-inverting. That means it will not introduce any kind of phase difference. That means if your input is like this, output will also be in the same phase. Only common emitter, even it's an amplifier, it will be like this. But of course, amplifier gain is very small, so you get almost the same thing, same input. This is wrong. So what we do here is, let me take the eraser. Let me take this part. Almost same. So that is the most important thing that you should remember. Let me take the pen again. So this is common collector. Another most important is this configuration is also known as emitter follower. Very, very important, especially in entrances, etc. They will ask, what is a emitter follower? It is a common collector, common base, common emitter, none of the above. In common way, it is called emitter follower. Emitter voltage always follows the base voltage and at the output. So it is a emitter follower, and as it has very high input impedance, it is used in buffer circuits. It is used as a buffer. This is also very important bit information. Which configuration is used as a buffer, because it has very high input impedance. So when I want to connect two devices to match their impedances, a high input device must be matched with another at the output. Then we use a common collector because it has no gain. It does not work as a voltage gain amplifier, so it will not change the input value, but it provides very high input impedance. So it acts like a buffer which do not change the voltage. So these configurations are widely used in impedance matching or resistance matching, like this. One device of other device of different impedances, you can use this. So, but the current gain of this configuration is very large. But the voltage gain is nearly unity, slightly less than 1. Practically it is 0.95, 0.96, something like this. This is another very important feature of this common collector. Very, very important. So before I conclude this, I have given a table. The following table gives a brief comparison of three transistor configuration. You can write this configuration: common base, common collector, common emitter. So when I consider the voltage gain for common base, as I have already told you, it is very high. For common collector, it is a low voltage gain, as you have seen, or nearly equal to unity, that is nearly 1. That means 0.9896. Common emitter, it is a medium gain. Something it may be from 10, 20, 30 to 50, something like that. Average gain. And gain will be low for common base, but common collector, just you have seen, very high. This is also medium. That's why we have some medium. But power gain for common base is low. It is average, but common emitter high. That's why we use these things. Similarly, input output phase relation is no phase relation, no inversion, but there is a phase difference of 180 degrees between input and output. So input resistance is low, input resistance is high, but it is neither low nor high, in between. Similarly, output resistance is high. Common collector output resistance is very low, but here the common emitter, it is average, in between, medium. That's why common emitter configuration is very widely used, or very, very widely used in most of the BJT applications. I think all of you have understood the concept behind these transistor configurations and their differences. Okay, we'll meet in another video with another topic on bipolar junction transistor. Thank you very much.